Welcome to the part 2 of our introduction to statistics. We will talk a little bit about what type of samples we could collect from a population. Generally, we would like to have our sample to be representative of the populations. So that kind of sample will be collected at random, but there are different ways to do that. The best way, or the most appropriate way to get the representative population would be by collecting something we call a simple random sample. I also want to point out that when we are talking about the collection of a sample, we are really referring to methodology of the collection. The end result, the sample itself, could be something that is going to be with a significant bias no matter what kind of methodology we use. So when we are saying that we are collecting something called simple random sample, we are really referring to methodology. The simple random sample has simple properties. If we are collecting 7 things from the population, what has to happen to have a simple random sample, every single item in the population should have the same chance to be in your sample as any other item in the population. Any 2 items in the population should have the same chance as any other 2, any 3 the same chance as any other 3, and on you go. Any 7 items in the population should have the same chance to be in your sample as any other 7. If you can accomplish that, the sample that you have is called simple random sample. But again, this is just about methodology. This methodology is actually available. It is called lottery. The end result, the sample itself, is not necessarily going to be representative of the population. It could have a bias. For example, if we are collecting numbers from 1 to 99 in lottery, we could end up with something that is 1, 1, 1, 1, 1, 1, 1. 7 numbers, all of them ones. That is not representative of the population, because in that population you also have even numbers, you have 2-digit numbers, and none of those is in your sample. Nevertheless, the collection, the lottery itself, is a methodology that provides us with equal chances for every single item, for any 2 items, for any 3 items, and so on. And that is the important thing to distinguish. I have another example here that says, if I'm a commander of a particular battalion of 900 soldiers and I need 300 soldiers for a dangerous rescue mission, if I want to collect that or select those soldiers by using methodology of simple random sample, I would use a roll call. I would write down all of the names of my soldiers on a piece of paper one by one, put it in a box, and then draw 300 at random. That would give me what we call a simple random sample, and I don't think anybody would have any complaint about any bias here. The second type of random sample that we often use in statistics is called stratified random sample. The difference is that sometimes certain type of bias is more important to us than the other. So for example, if we are collecting information about political opinion or support for a political candidate, which is done by polling, we would like to have in that selection the bias of gender, of income level, of religious affiliation, of age to be eliminated, because we know that people have political opinion that is dependent on their age, on their income level, on their gender, on their religious affiliation. So sometimes we want to eliminate those rather than something else. In that manner, so if we want to do that, we would divide population in stratas. Strata as a layer. So if you divide population in groups, stratas, and then you draw proportionally from those groups to avoid bias, we would call that stratified random sample. In case, for example, in gender, we know that in the last election we have probably around 53% females and 47% males as a voting population. So if we want to have a political opinion about some kind of candidate in the next election, we would probably want to have in our sample 53% females and 47% males. So if I have a sample of 100, I would say I need to have 53% females and 47% males. I could also do the same thing for age groups or for income level and so on. In this example about soldiers, if we have a 3 company and the first company has 270 soldiers, the second company B 270 soldiers, the third company C 360 soldiers, we would take proportionally from the first group, from the first company 90, there will be a third, from the second company 90, there will be also a third, and from the third company 120. That way I would not deplete any company in particular. That could be an objective of a commander. Then we also use sometimes something called systematic random sample. Systematic random sample is usually something that is available by a computer program or a simple decision. If you know what portion of population you want. If you don't, then you will not be able to do the sample. And here is the idea. In case of those soldiers, I would use a die. A die has 6 sides. On one of the side you could have, you will have 1. On one side you might have 2. On one side you might have 3. And the other 3 side would be 4, 5, and 6. So if I roll a die, I would probably be able to get 1 and 2. I could also get 3 and 4. And I could also get 5 or 6. So each one of those is with 1 out of 3 chance, right? I'm assuming fair die. So now if I have a roll of these soldiers with all of the names, if I have 1 or 2, I would select the first soldier in that roll. If I got 3 or 4, I would select the second soldier in that roll. If I have 5 or 6, I would select the third soldier. And then, since it's 1/3 of the population that I need to select, 1/3 of the battalion, I would select every third next. So in case I have number 1, I will have number 7 in the row, number 4, number 10, and number 13, and on you go. In case I selected number 2, I will have the next one would be number 5 on the roll, number 8, number 11, number 14, and on. In case I selected the third soldier on the roll, the next one would be number 6, the next one would be number 9, the next one would be number 12, number 15, and again in that manner You could continue, and you would have 300 soldiers that you need to have. Again, you need to know what portion of the population you are collecting. If it's a fifth of the population, then every fifth. What is the bias here? Well, there is a bias because, for example, you could have 1, 4, and 7 on the roll that are selected, but just rolling a die with 1 and 2 as a result of the roll. That is 1 out of 3 chance. But you could never have 1, 2, and 3 on your roll selected. Because if you roll a die and the result is 1 or 2, there will be the first person selected. If it's 3 or 4, there will be a second person selected. If it's 5 or 6, there will be a third person selected. So there is no chance that all 3 would be selected. This violates the principle of simple random sample, because these 3 and these 3 soldiers do not have the same chance to be in your sample. These 3 have a chance 1 out of 3. These 3 have a chance of 0 to be in your sample. It looks like there is no bias here, but bias is present, although that might be irrelevant to a commander, so he might just do exactly that. Then another way of collecting a sample would be cluster sampling. Now that sounds very similar to a stratify, a random sample, but it isn't. Cluster random sample is selected in a way that the whole population is divided in clusters, and then clusters are randomly selected, and everything from the cluster, or most of the things from the cluster, is taken. So for example, that could be done in a way of polling. If I need to have opinion from people, I would probably have a limited amount of poll workers that could help me, and I would probably assign zip codes to them. So I would have, if I have 7 workers to help me and I have a 25 zip codes, I would randomly select 7 out of 25 zip codes and give to each one of my workers a duty to select people from that zip code. Now, I'm not saying that everybody's going to be selected, but as you see, 18 zip codes would not have a single representative in your sample. And that is often done. So for example, in this situation, we could possibly have a platoon, number 1, number 2, 900 soldiers in a battalion would warrant approximately, I would assume, 9 platoons. So you might want to make a selection of 3 platoons at random, and that way you would have 300 soldiers. Let's say this, and this platoon, just at random selection. So you have to do some kind of lottery drawing to get that, and then platoon number 2, 3, 5, 6, 7, and 9 would not be selected, while these 3 go on a mission. Now, what's the benefit of that? In this particular case, I guess you keep the command structure, right? Platoon number 1 has a commander, number 4, and number 8. So all you have to do to keep command structure is to appoint one of those 3 commanders as a commander of the mission. And that way you don't have to work on a command structure. If you would have to select some other way, you would probably need to find out how can you get the commanders of the mission. And finally, we have convenience random sample. That is something that would be readily available, as I described in the part 1 of the lecture, to warm up parking lot. and collect information about the mileage per gallon of cars that are in Walmart parking lot, that will be a convenience random sample. If I want to get the information from the population of all of the cars that are on the road in the United States, I am obviously going to have bias sample, because it's going to be a representative of something that is in central Long Island, but not in the all of the population of all of the cars in the United States. So you ought to be aware of that, but it's very easy to do, or should I say easier than any other way. I would like to point out also that there is a difference between the cluster random sample and stratified random sample. In both cases, you're dividing population into layers. In case of stratified random sample, we call that stratas. In cluster random sample, we call that clusters. But the difference is that in stratified random sample, you're taking proportionally from a strata, from a layer, while in the cluster random sample, you are selecting cluster at random, but then you're taking everything from that cluster, or almost everything that you can, and that's the difference. It's not the same. Okay, this would be the story about sample collection, and that concludes story about introduction into statistics. The next time we will talk about histogram.